Okay folks, welcome to lecture 20. We're looking at formula manipulation part 2. But first we'll just take a look when sums go bad. So this was a bit of a calculation error. Essentially Amsterdam decided to give out, they gave out 188 million to 10,000 poor families living in the city. Unfortunately, they'd made an error. They'd only planned to give out 1.88 million, and essentially for the software was programmed in cents and not in euros. So people were receiving kind of 100-fold increase over what they should have. So they recovered most of the money before it kind of became public, but they still lost out kind of about 1.5 million overall. So again, very small error, just not really watching the P's and Q's. So do be careful out there, folks. So now we'll just have a quick review first of what we kind of did in the last lecture before we push on. So we're going to look at a complex formula. It's for a geostationary satellite. These are like the Vodafone satellites that keep our mobile networks going. And this is the formula that dictates how far R is the distance from the center of the Earth to the center of the satellite. That's R. T is the period. How long does it take the satellite to complete one revolution around the Earth? So there's lots of kind of fairly heavy maths in here, but we're just going to try and manipulate the formula to make R the subject. So we want this guy on his own. So taking a look, guys, just at the order, the 3 is closest. That's going to be the last thing to go. Then there's the GM is next closest, second last, the square root, and the 2 pi is furthest away. So we're going to get rid of the 2 pi first, then we're going to get rid of the square root, then we're going to get rid of the GM, and finally we're going to get rid of the cubed. It's very important to decide the order in which you work. You always work from the outside in towards the subject. And this is, you'll be told what the subject is. So first of all, we just color the subject in blue. And then we kind of decide, well, what's first to go. So the furthest thing away is the first to go. It's joined on by multiplication. So to get rid of it, we're going to divide both sides by 2 pi. So when we divide this side by 2 pi, they're going to cancel out. We also have to divide the left hand side by 2 pi, and that's what gives us this. Now we can see in red the next thing we want to get rid of, the next furthest thing away, is the square root sign. The inverse of square root is squared, so we're going to square both sides. And these will cancel out, the square root sign and the squared. Now we want to get rid of GM. It's joined on, we can see, by division. The opposite to division, the inverse operator to division, is multiply. So we're going to multiply both sides by GM. And that's what happens there. These will cancel out. Now again, guys, you don't need to show these intermediate steps. It's perfectly fine to write your solutions the way I have them. Finally now, guys, we can see the last thing we want to get rid of is the cube, power of 3. One option here, guys, just is we could raise both sides to the power of a third if we wanted to do things with powers. But we're just going to, because we started with the surd symbol, that symbol, we're going to use that again. So in surd form, to the power of a third is the same as the cube root. So we're going to get the cube root of both sides. Again, when we get the cube root of this side, the cube and the cube root will cancel out. Finally then, guys, we're pretty much there now, but always write your subject on the left. Don't leave the subject here on the right. you always write the subject on the left. And then as your last step, guys, we'll see this towards the end, then you feed in any variables. If you know what G is and M is, you only put the values in, guys, at the very end. Do not feed them in at the start and then start throwing them around. But we'll see that later on. So now we're going to take a look at kind of what's new in this lecture. That was just a review of last lecture. We're going to take a look at what I call double trouble, but it's really where the subject appears more than once in the function. So it could be 3 times, could be 4 times, but the principle is the same. So sometimes the subject will appear more than once. First thing you do is get rid of any fractions by multiplication. We'll do loads of examples, guys, so this will make more sense as you see it worked out. Use common denominator if we need to. Multiply out any brackets. Gather all the subject terms to one side. So there should be several of them, that's the nature. Gather all those to one side and everything else move to the other side. Then use brackets to factorize your subject. This is what we were doing 2 lectures ago. Factorizing, pulling out what's common. Obviously, if every term on one side has the subject, that should be common. This is the whole point of what we're doing. So the whole point of this exercise, guys, is now we'll have the subject on its own. Our last step is the subject, those brackets, the other factor, these brackets, they're joined on by multiplication. So we're going to get rid of those by division, and we'll finally be just left with x is equal to, and those brackets will be on the bottom. So again, it's easier to kind of explain by example. So we'll work through, I think, 2 or 3 of these examples, and then you guys can have a go yourselves. So here now, there's a few decimals, don't be put off, everything is still the same. So we take a look at our list of things we want to do. First of all, we want to make B the subject. And here's just a quick summary of the technique. Now, in this case, guys, there's no fraction terms, there's no rational terms to be a bit more formal. There's no brackets, so we don't have to worry about them. So my first step, guys, is I want to gather terms. I'm going to bring this over to this side so that everything will be positive. You don't have to do that. We could bring the 1.5b over, but then you're dealing with negative signs. So I want to gather all my b's to the right hand side. I want to move this minus 2b, opposite to minus, is plus 2b. So now I'll be adding 2b to both sides. And obviously these guys here will cancel out on the left. So c is equal to 4.1d. Here's our b terms. But now we've got this, guys. We don't want this here because it doesn't have b. We want to only have b on the right hand side. B terms, terms containing b, to be a bit more formal again. So I want to get rid of this. It's plus 4.1d. So to get rid of it, I'm going to subtract 4.1d from both sides. So this, guys, is what gives that term. Oh, bring it over and change the sign. Bring it over and change the sign. That's not really what's happening. What's happening is you're applying the inverse operator to both sides. It's a little bit more of a mouthful, but it's a lot more kind of rigorous, and it'll stand you good stead to say that rather than bring it over and change the sign. So now we gather all the b terms together on the right. We have 1.5 of them plus 2. So they obviously add together to 3.5. So a big problem, guys, what I'm saying is often people think I need to get rid of the 3.5, so they bring it over and they change the sign. And that's the problem. That's incorrect, because 3.5 is joined on by multiplication. So that's what I'm saying all the time. You've got to see what operator links the unwanted quantity to your subject. It's not the value 3.5 that really counts, it's the operator that counts. We want to undo a multiplication, so we're going to divide both sides by 3.15. This gives me this subject, but at least I have my subject on its own. And finally, now I write my subject on the left. So the main principle, guys, is get rid of any fractions, multiply out your brackets, gather the subject terms to one side or the other. Doesn't matter. Choose the one, to make your life easier, try and make your subject terms positive. Gather them together. In this case, it's okay, there's only numbers, we don't need to factorize. And now we've got the subject on its own. That's the whole point of the exercise. All of the work, guys, is just to get here with the subject appearing once. And then it doesn't matter what it's multiplied by, we can put brackets around it and get rid of it by division. So we look at another one, guys. The decimals make that one look a little bit kind of confusing. Here's another one with just x and y, but we can see x appears twice. So we take a look at our list of things we need to do. First of all, remove any fractions. So put brackets around whatever's on the bottom, guys, and multiply both sides by that. And then they'll cancel on this side. So we'll take a look. First step, we want, like I said, we want to get rid of the fraction term. We want to remove the denominator. Multiply both sides by whatever the denominator is. In this case, it's 2x. Now remember, number first, then everything alphabetical. So y by 2x becomes 2xy. And here's then just what was left, the numerator of the rational term. I hope these words are becoming a bit more familiar. Now, guys, I want to bring the 4x over to this side. I'm just doing that this time. I would normally go the other way, but I'm going to kind of show you how you work with a minus if you need to. So I want to get rid of this. It's plus 4x. So I'm going to subtract 4x from both sides. When I do it to the left-hand side, to the right-hand side, they'll cancel out. And then I'll also do it to the left-hand side. So it's very important, guys, to realize we're really doing the same thing to both sides. We're applying the same carefully chosen operator to both sides. So now I've brought my 4x over with minus 4x. It's disappeared off the right hand side. Now I can see every term on the left. I've gathered all my subject terms. All the terms on the left have my subject, and everything that doesn't have the subject is on the other side of the equal sign. I'm going to factorize for x. In the first term, x is multiplied by 2y. And then in the second term, x is multiplied by minus 4. So now I've got my subject on my own. So this is the first line, guys, where the subject appears. There's just one x in the function. And that's our whole goal, is to try and factorize. You have to gather and factorize. Now we're nearly there, though. Oops, sorry. We're nearly there now. We have x. We just simply want to get rid of this factor. It's joined on by multiplication. So we divide both sides by the unwanted factor. And that gives us this. Now, here, guys, my subject is on the left. I don't have to adjust. But if at all possible, you try not to start an expression with a minus sign. So we can actually change, we can multiply the top of this term by minus 1 and the bottom by minus 1. So we're only doing it to the right hand side. Remember, with our fractions, we're not changing the sign. Remember, we're multiplying by a minus over by a minus. We're really multiplying by minus 1. But when we do this, guys, it essentially changes all the signs, all the terms. Each term changes its sign. And it looks like that. So we've gone essentially from having two minuses and a negative term with a little bit of kind of a little sidestep. We've now got a positive expression and there's only one minus in it. And that's kind of, again, on Moodle, guys, Moodle would see both answers as correct. They're both mathematically equal. They're both equivalent. We look at another one, guys, a little bit more complex. This is just what the curve looks like of this function. We'll be looking at these next semester a little bit more, looking at curves in more detail and how functions behave, and then we'll be linking those functions to kind of real world science scenarios. Here's a trickier looking one, but again we can see x appears twice, and that's what we're asked to isolate. Here's our little list of things we need to do. First thing we need to do, guys, is get rid of the denominator. We're going to multiply both sides by that. That's going to bring in brackets then, so we need to multiply out our brackets next. So this example kind of takes us through every step that we need to do. So here again, like I said, first thing I want to do, remove the fraction terms. I want to get rid of this. Doesn't matter how big it is, guys, just put brackets around whatever's on the bottom, on the denominator, and multiply both sides by that. Now we need to multiply out any brackets. Remember from algebra, the 3y comes in and multiplies by each term. So this is just expanding the brackets that we did about 3 weeks ago, I think. So we multiply out our brackets. Remember, write everything alphabetically, x, y again. And now, guys, we can see, well, we have a next term here and we have a next term on this side. We want to gather all these together. So I'm going to bring this guy over. How am I going to do that? It's a plus x. So I'm going to subtract x from both sides. Again, these will cancel out, but I'll obviously have 6xy minus x, that's the new thing that's just appeared, and then minus 15y is all equal to 1. Now these two terms have x, but this one doesn't. That's why it's red. He's the next to go. I'm going to bring him to the other side because he doesn't have x in it. He's kind of unwanted on this side. It's reserved exclusively for x terms. So main thing, guys, is not the 15y that's critical, it's the operator. It's joined on by a minus. To get rid of it, I need to use a plus. I'm adding 15y to both sides, so they'll cancel out on the left hand side. But obviously then I'm going to have 1 plus 15y on the right hand side. So now here's all my x terms. I've colored them in red. So we're going to factorize next on the left. But just check, guys, that there's no x terms on your other side that you haven't forgotten. So we're going to take x out. Here in this term, guys, x is multiplied by 6y. And then in this term, guys, x is multiplied by minus 1. Write that out a bit tidier, factorize for x. And now we're nearly there, guys. We've got two factors. One of them is what we want, our subject. The red bracket is what's unwanted. I don't want that. So I'm going to divide both sides by this red bracket. Again, when I do that on the left, they'll cancel out. But when I do it on the right, I'm going to divide the right hand side by 6y minus 1. You can put the brackets around it or not. It's kind of neater not to. But just while you're working through it, it might be no harm. And there's our answer. Like that. Do not, guys, be tempted to cancel your y's. We discussed that in the algebra lecture. We can't cancel unless every term has what we want to cancel by. Be careful. Do not kind of be tempted to over cancel. It's a worse mistake than under cancelling. So now, guys, here's an example for you to try. So just give that a go. I'll let you pause the video. And then we have another one slightly more difficult. So be careful, there's two problems here, but the numbers will give that away. And the second example we did just earlier will help you work your way through this one if you do get a bit stuck. Remember your little list of things to do. So that's the kind of first part of the lecture, guys, double trouble. And here's one for you just to try. It's triple trouble. So here's the subject appearing 3 times. Now it's not too bad. It's at least there's no fractions and there's no brackets. So just give that one a go as well. You can see there's 3 terms with x. I'd bring him over, factorize for x, and off you go. So yeah, just pause the video, give that a go. And now we're going to take a look at the last section. We're going to look at the applications of function manipulation. So really, guys, there's actually nothing new here. We just do our function manipulation, but then we'll also be given values for the variables that appear on the right hand side. So here's an experiment. The following details were recorded. And using one of Newton's linear motion functions. First of all, we want to manipulate the equation to make u the subject. If we take a look at what we know, guys, we know all the other variables except u. We don't know u. That's why we want to get him on his own. Once we get u on its own, guys, we're asked to determine what its value is. Now u is the initial velocity of the ball bearing. We've measured its final velocity, we've measured its acceleration, and we measured the distance it travelled. So this is our function. U is our subject. The squared, guys, is closest to it, so that's going to be the last thing to go. The 2as is furthest away. That's the first to go. It's joined on by a plus sign, so we're going to subtract 2as from both sides. Now we want to get rid of the square root. Sorry, the squared, u squared, we want to kill that, get rid of it. So to get rid of a squared, we use a square root. So what's going to happen now, guys, is be very careful. We're going to square root both sides completely. You kind of put brackets around everything on, you know, you're doing it to both sides in entirety. That's what's very important. So when we get the square root at the right hand side, that kills the squared, and you can see the left hand side has been, so you don't bring the square root, guys, in like this. It goes over everything on the left hand side. So finally now, guys, we just need to write our subject on the left. And now we go to part B, where we're given values for V, A, and S. And we feed these in. 12 squared. When we work out 12 squared, that's 144. Here, guys, we have 2 by 50 is 100. Multiplied by 0.8, that's 80. 144 minus 80 is 64. Square root of 64 is 8. So most of these problems, guys, should work out fairly straightforward without you needing to reach for the calculator. I know you wouldn't anyway, but just in case you'd be tempted. So here's one for you guys to try now. Very similar. It's different linear motion equation. The exact same process though. We need to get A on its own. And then we're given values for u, s, and t, and asked to calculate a. So essentially, guys, we need to have a on the left, we need to have u, t, and s in some kind of arrangement on the right. Obviously, the desired arrangement. And once we have that, then we feed in the 3 values. Here again is a problem, unless you've kind of studied DC circuits and some kind of electronic engineering, you probably haven't met this. This looks at the resistivity of resistors in parallel. I won't get into it, guys, but it's a big... Resistors can be in series, like that. And a resistor, guys, is like a light, you know, it's any kind of a thing that draws a load. It's, yeah, they're a bit more complicated than that. I won't get into it. We're not studying it. We're just looking at the formula. So we're asked to rearrange the function to make R1 the subject, this guy. And then we're given some information about the circuit. We're given the value of R and we're given the value of R2, and we're asked to calculate R1. So our first task though, guys, is to get R1 on its own in terms of the other variable. We need to isolate R1. So here's our equation. R1 is in blue, that's the subject. We're trying to leave him on the right hand side, strip everything else away. What's furthest away is this fraction plus this fraction. We want to get rid of it, so we're going to subtract that fraction from both sides. Now, guys, we need to do a little bit of maths. We need to actually get the common denominator. There's a few ways of doing these, but I think the most straightforward way, guys, what we're aiming for is to have a single fraction on the left and a single fraction on the right. Once we do that, guys, we can actually flip both sides. So 2 over 1 is equal to 8 over 4. That's still valid. So that means it's a valid operation. That's what I'm aiming for. So I want to get the common denominator on the left hand side. Remember, if we were doing this, 1 over 3 minus 1 over 5, first thing we'd do, it'd be multiply the two denominators and keep our sign. So that's what we do. Now here with our fraction, guys, we'd multiply the fraction on the left above and below by 5. So this fraction here I'd multiply above and below by R2, because I want R2 on the bottom, but I must do the same to the top. And with the other fraction, the number fraction, I'd multiply above and below by 3 to get me 15 on the bottom. And that would give me that. So the rules of fractions, guys, still apply, but you still obviously you've got to be careful. We've now got a common denominator, so we can write our fraction with one denominator. And this is what we get. And now, guys, this is what I've achieved. Even though it looks quite, it's messy, but it's one rational term. We have one rational term on the left, and I have one rational term on the right. And now I can flip both sides. To be a little bit more formal about it, what I'm actually doing, guys, is getting the reciprocal of both sides. That's what I'm doing. And remember, with the fraction, when I'm dividing by a fraction, I flip and I multiply. So that's really what I'm doing, but we can just say flip both sides. It's much easier to understand. You can only do it though if you have a single fraction on each side. So now we've flipped both sides. And finally, we can write my subject on the left. So there's quite a bit of maths in that, guys. You know, I'm not pretending it's easy, but it's just to try and understand that the stuff we learned back in fractions is absolutely valid when we're dealing with variables. So now from the question, we were told R, the resistance of the overall circuit, was 0.8, and the resistance of R2 was 1 ohm. That symbol there, you guys know it as omega, I'm sure, but it's the symbol for an ohm, the measure of resistance. We feed these values in. We get 0.8 on the top, 0.2 on the bottom. So the resistance of R1 is 4 ohms. So now, guys, there's an example here. I'm not sure if you do this thing in physics, but this is to do with measuring the focal length of a lens. So here's the lens. Here's an object. And u is the distance here. U is the distance from the object to the lens. You don't really need to know all this, but it's good to know. V is the distance from the lens to the screen, that's V. And F is the focal length of the lens. The relationship between these is given by this function here. 1 over f is equal to 1 over u plus 1 over v. So hopefully, guys, you'll see it's the exact same as the previous example, only the letters have changed. Rearrange the function so that u is the subject. And then we're given values for f and v and asked to calculate u. So it's essentially, guys, the exact same process as the previous example, but just using different variables. Final example then, guys, my favorite problem of the whole course, to do with the brightness of a star, the luminosity. It's related to the radius of the star and its temperature. So here's the function, luminosity. Both of these are constants, by the way. Stefan's constant and 2 pi. So we're asked to rearrange the function so that r is the subject. And then we're given some figures, but they're your favorites. They're scientific notation figures. And you're finally asked to determine the radius of this star. So I'm just going to leave that with you guys. See how you go. It is tricky. You know, it's you certainly need to bring all the skills we've learned to bear to work it out, and just see how you go. I'm tempted to write out the answer. You'll know the answer is right when you get it, guys. It's a number. Yeah, it's yeah. It should work out nice and neatly for you, but don't be surprised if it doesn't either. So these are the values then. Take pi to be 3.14, and this is a slightly adjusted Stefan's constant. Feed those in, watch your units. Yeah, and if you can get this one out, guys, I think you've learned quite a lot. So, finally, guys, that brings us to the end of this lecture and to the end of the module 1. So, Maths for Science 1 finishes here. So, thank you very much, guys, and hope you learned something. I hope you found it kind of challenging, but also manageable. So look, I'll finish up here, and yeah, take care. We'll chat to you soon.